Hello students, good evening. Today our topic is fluid mechanics. Now see, when we say the word fluid, what do we understand? Fluid is something which flows. Now, from the basic states of matter, you know that we have solids, liquids and gas. Now, liquids and gas, they can flow. So, these are fluids. So, what makes them fluid? You will see, like if we see a solid structure, if we see a solid, you will see solid can take force in all directions. In all directions means they can, on the surface of the solid, you can apply force which is perpendicular. At the same time, if you apply the force which is parallel to the surface, that is the shear forces, solid can also take that. You have studied in the chapter of elasticity. But fluids are those kind of materials, are those kind of things, you can say, which can't take any shear force. If you give any shear force, that is a force which is parallel to its surface, their surface will slide. This happens in the liquid and also in the case of gases. So for liquids and gases, we term them as fluid. Okay. Now this fluid mechanics, it can be broadly divided into two parts. One is the hydrostatics and one is the hydrodynamics. We're using the word hydro because commonly we deal with water, but it does not mean that this the laws and everything are not applicable to other liquids. They are also applicable to other liquids, but just water is the most common liquid and we are naming it hydro. Now hydrostatics means when the fluid is at rest, and hydrodynamics is when fluid is at moving. Very simple. Today we will study laws of hydrostatics. For hydrostatics, you do have a concept of pressure. Now, how to find the pressure applied by a liquid? Now, for a liquid, let us take a liquid. Let us consider a liquid column, say, whose height is h, the cross-section area is A, and the liquid is of density, say, rho. So, what will be the pressure at this cross-section area is nothing but the force per unit area. Force at this base is nothing but the weight of the liquid. Now, what is the weight of the liquid? Weight is nothing but mass into gravity. Now, mass is nothing but the volume into density into gravity. Now, what is the volume? It is A, cross-section area A as uniform cross-section, into height, into rho, into gravity. Now, definitely pressure, basic knowledge of pressure that you know, force per unit area, force here is weight, that is A H rho G divided by A, that is H rho G. Now, this is a very common equation that you know from your previous class, that pressure in a liquid column depends on the height of the liquid column, the density of the liquid, and the acceleration due to gravity. If you notice that there is no cross-section area A term, so it means the pressure applied by a liquid at a depth, it depends only on this depth from this free surface. It does not depend on the area of the base. So if you take different shape utensils or vessels, you will see, and all are of the same height h but of different cross-section area, you will find maybe the force applied at the base will be different, because force is nothing but the weight of the liquid contained within the vessel. But the pressure, if the height is same, pressure will be the same. Pressure is same. These things you know about liquid pressure. For liquid pressure, we also have another thing, that is it comes from the same thing, that is liquid pressure or fluid pressure, you can say. It it is applied, it is same in all directions. Say if we consider a point within the liquid, you will see pressure applied in all the directions is same. And there is another very interesting thing, that a liquid seeks its own level. It means what? Say we have different shaped vessels connected, all connected through a common channel. You will see if you pour water in any one of them, water will go up to all the vessels at a same level. Because what? Because the main principle is what? The pressure at a particular level will be the same. It will not depend on the water contained within the vessel or the amount of, what is the volume, what is the mass, what is the weight. No, it just depends on the height, or you can say the depth of the liquid from the free surface. And as the fluid, it will flow from higher pressure to lower pressure. So finally what will happen, when the whole of the the whole liquid, whole fluid, when it is in equilibrium, that is no fluid is moving, then definitely this height or the depth will be same. So it means liquid seeks its own level. Seeks its own level. Okay. Now, pressure, in what unit do we measure pressure? For any pressure, you know, which is force by area, definitely the unit will be Newton per meter squared, which we say Pascal. For specifically atmospheric pressure, we use a unit called 1 atmosphere, which is nothing but the pressure of, that is pressure by the atmosphere. It is nothing but the 1 atmospheric pressure, which is about 10 to the power 5 Pascal. It can be calculated. If you calculate, if you know what is the height of the atmosphere, the average density of the air, and the gravity, it can be calculated. 1 atmosphere, we measure the atmospheric pressure with it. Now, as we are talking about atmospheric pressure, one thing we should keep in mind, that as we are saying that at a depth of a fluid from the free surface, the pressure is H rho g. But H is what? H is the height of the liquid column. But what about this? The above the free surface, there is an atmosphere. So definitely at the free surface, the pressure is not 0, but it is P0. So the total pressure, if we actually write the total pressure at this point, is not H rho g, it is atmospheric pressure plus H rho g. Atmospheric pressure plus H rho g is the total pressure at a particular point. Now, for our own purpose of, like, we are comparing the pressure in two vessels or some other purpose where the atmospheric pressure is the same, we don't need to add this atmospheric pressure all the time, because this part is common to both. So we basically work only with the H rho g, and so this H rho g has a special name, is called the gauge pressure. From where does it come, this gauge pressure thing? Gauge is also meaning that is a difference. It also comes from an instrument called the manometer, which basically measures the difference of pressure. It is having pressure of a gas which can be, so this gas pressure and the atmospheric pressure, that difference, it can be measured, which is called the manometer. Measures difference of pressure. Okay. Now we'll discuss few things on density. As we have seen, the pressure depends on the depth, the density and the gravity. Now density, rho, you know that is nothing but mass by volume. So it is nothing but is measured in kg per meter cube or gram per centimeter cube. Now what will happen if, suppose we are mixing two liquids of different mass and different density, what will be the total density? If we can try to find an equation for that. Say mass, a liquid of mass m1 and density rho1 is measured with a liquid of mass m2 and density rho2. What will happen? See, for mass m1, density rho1, the volume is nothing but m1 by rho1, and for this volume is m2 by rho2. So what will be the total volume? Is this plus this. The total, then the density of the mixture, is equals to nothing but the total mass, that is m1 plus m2 divided by the total volume v1 plus v2, that is m1 plus m2 divided by m1 by rho1 plus m2 by rho2. If you cancel, see m1 plus m2, m1 plus rho1, yes, volume equals to total mass is m1 by m2. Is it not cancelling? m1 by rho1, v1 equals to m1 rho1, the total mass. Okay, let me see. So this will be, this is the density of the mixture, total volume. Okay, now you see, now if m1 equals to m2 equals to mass m, if we take both the masses to be the same mass, so what we are trying to consider, that is the masses same but of different density, of different liquid, then the density of the mixture will be what? This will be 2m, this will be m by rho1, this will be m by rho2. Now it will cancel, the m will cancel, and it will become 2 rho1 rho2 divided by rho1 plus rho2. So we are mixing two liquids here, m1 equals to m2 equals to rho. When the masses are same, then the density will be 2 rho1 rho2 by rho1 plus rho2. It is nothing but the harmonic mean of the two densities. Now what will happen if we mix two liquids, rho1 and rho2, when the volume is same, when volume V is constant, then same rho of the mixture is nothing but the total mass by the total volume. Total mass is what? It will be, volume is same, so rho1 into V plus rho2 into V, and this is V plus V. So finally that is 2V, it is rho1 plus rho2 divided by 2. So the density of the mixture when the volume is constant will be nothing but the arithmetic mean of the two densities. Now what will happen if the temperature, it changes, if what will happen to the density. So we are trying to find out change in density when temperature changes. Now you see, most of the liquid, it expands with the temperature. So let V is the initial volume, it has increased to V dash, such that it will be V1 plus gamma del theta. Del theta is nothing but change in temperature, and gamma is the temperature coefficient of the liquid. And you know it will be positive for most of the liquid. So this will be the new volume after when the temperature has increased, has changed by del theta. Then the density rho dash will be m by v dash, that is m by v 1 plus gamma del theta. Now m by v is the original density rho 1 plus gamma del theta. So we can write rho 1 plus gamma del theta to the power minus 1. That is, now temperature coefficient is a very small value, so it can be, if you expand it binomially and then we can ignore the very small terms, it can be written as 1 minus gamma del theta. So finally we can say that the density of a liquid with temperature, it decreases with this factor. Okay, now we'll come to another important part of the fluid of hydrostatics, that is called the Pascal's law. Pascal's law, you know what is that? That is, Pascal's law says, Pascal's law is applicable only to enclosed liquid. And also we need to remember also this liquid, Pascal's law is applicable to liquid, not only they are enclosed, the liquid should be incompressible and non-viscous. So when we talk about enclosed liquid, and suppose there is a balloon, it is filled up with water, it has several holes on its surface. Normally you will see water is not coming out, but just if you press a single point on the balloon, you will see water will be sprinkling out from this all the holes. How is it happening? You are giving the pressure in one point, but water is coming out from all the points. Why? Because the pressure that you have applied, it is transmitted equally to all the parts of the body. And if it is not enclosed, this transmission of pressure will not take place. So Pascal's law states that when a pressure is applied to an enclosed liquid, then pressure is transmitted undiminished to all the parts of the liquid. And this Pascal's law is used in many useful engineering application, such as one is the hydraulic lift. What is that? A very interesting application of this. A vessel-like structure like this, a U-shaped, but you will see one area is much smaller than the other area. The thing that would be lifted is kept on the broader area, and a force F1 say is applied on the area which is which is small. Then see, if this area is A1 and this force is F1, what will be the pressure? Pressure generated will be F1 by A1. Now this pressure, as the whole system is enclosed, will be transmitted equally to all the points of the of this piston, of this liquid. And if we consider this piston, say its area is A2, so finally what will be the force F2 with which the force with this piston is rising up is nothing but this pressure P into A2. Now this pressure P is nothing but F1 by A1 into A2. So if you see, F2 divided by A2 will be equal to F1 divided by A1. That is, the ratio of the forces is nothing but equal to the ratio of the areas. So in order to generate a very high force, all we need to do is design a chamber like this, a vessel like this, where this area will be much broader. We will solve few problems with this concept, then I'll move on to the next concept. Okay. Let us see. The first question is a very interesting question on the we have said, like, liquid, the pressure in a liquid in a particular level, the pressure is same. So we are using that concept, and let us see in a problem. Okay. A U-tube of uniform cross-sectional area and open to the atmosphere is partially filled with mercury. If the equilibrium, now this is mercury and this is water. So water is poured in both the water, this is water. This is the U-tube. This part is the mercury. And water is poured in both the arms of the U-tube, such that if you observe, this water is of this length, this water is of this length, and these lengths are also marked. See the this and this level, this is H2. The difference between these two levels is H2, and difference between these two levels is H1. Now what we have to find out, H2 is given equal to 1 centimeter. We have to find out H1. Now how to approach this kind of problem? You will see this kind of problems plenty. First, take any reference point where you can balance the pressure in an equilibrium. See mark the word, the equilibrium. So when it is an equilibrium, then definitely the pressure at 2 points in a liquid system will be equal. So we can say, if we mark this as point A and we say this is point B, we can say in equilibrium PA will be equals to PB. PA will be equal to PB. Now what is PA? PA, if you see, the pressure of by this water column plus the atmospheric pressure. So, and pressure at PB is what? Pressure by this water column, pressure by this mercury column, and the atmospheric pressure. So we are equating both of them. So pressure at PA will be what? PA, if we write PA, see first atmospheric pressure, so let us write P0 plus, see this is H1, this is H2, let this part we are naming as H, say in between part is H, so we can write pressure P0 plus H1 plus h plus h2. Now h, this is the total height. The density is density of water definitely into gravity. And what is pressure B? Pressure B is C PO, atmospheric pressure, plus this height is nothing but the h. If you follow, it is h rho of W into G, because this is the pressure by the water column, and this part, that is H2 rho of Hg into G. Hg means mercury. So now if you equate it, you will see obviously this 2 will cancels out, this 2 will cancel out, and you see see H1, see H into rho Wg, that is, this part is equal in both. So H rho Wg will cancel out from both the side. So in the right, in the left hand side, what will remain? H1 plus H2 rho Wg, and in this it will be H2 rho Hg into G. Now see, you know all the thing except H1. H2 is 1, it is given. This is density of water, that you know, 1 gram per cc. You can convert it into kg per meter cube if you need it. This also you know, 13.6 gram per cc. G cancels out, so you can find out H2. Understood? This is one kind of problem that we get in pressure. Now let us solve another problem. One more problem on Pascal's law. Now if you remember the Pascal's law, what we have to do here also, that is, the pressure is equally transmitted in all the parts of the liquid. Let us see how we can apply the concept. For the system shown, the cylinder on the left has a mass of 600 kg and a cross-sectional area 800 centimeters squared. The piston on the right has cross-sectional area 25 centimeters squared and negligible weight. If the apparatus is filled with oil, the density is given. What is the force F required to hold the system in equilibrium? Now see, if the force is not there, because of this weight, it will generate a pressure and it will go up. So we are holding the we are holding the system in equilibrium by applying a force. Now see, we can also apply the previous rule, that is, in an equilibrium the pressure at a particular level will be the same. Now what is happening? We'll do the same thing. Let this be A and let this be B. Pressure at A is what? That is weight of this 600 kg into G divided by this area. This area is 800 centimeters squared. And what is pressure at B? Pressure at B is nothing but, see, we are applying the force F. The area, it is 25 centimeters squared. Now it is generating a pressure at this point. It is generating a pressure, what? Force by 25 centimeters squared. This pressure is equally transmitted throughout the liquid, but it is also having a liquid column. So this pressure will be liquid column pressure plus the pressure which is generated by this force. So definitely it will be what? F by 25 centimeters squared plus this liquid column. Liquid is what? That is, height is 8 into we'll just write H rho oil G, where H, you know, it is 8 meter. Rho is nothing but given 0.78 gram per centimeter cube, and G, right? Now if you equate it, you will see only force is F is unknown. Two things you need to remember. See, here the height is given in meters, whereas the area is in centimeter square. So whenever we do this kind of problem, we have to convert the area. We have to convert the convert the units. So 1 centimeter square, you know, that is 10 to the power minus 4 meter square. So always when doing the final step, you have to convert the unit and you can solve it. So I think you have understood the concept of how you're applying the laws of pressure. Okay. Okay, now we are coming to another important topic called the Archimedes principle and the flotation. Archimedes principle and the flotation. This also you have studied in your previous classes, that when a body is submerged within a liquid, it experiences a force in the upward direction, which is called the buoyant force or upthrust, which is equal to the weight of the liquid displaced. Now, if this is the volume of the solid inserted within the liquid, then it is displacing same volume of liquid, and the upthrust or the buoyant force will be equal to the weight of the liquid displaced. Let us see how we can find that. Let us consider a cylindrical solid like this within the liquid. Let this height be h1 and this height is h2. Let the density of the liquid is rho L and the density of the solid is rho S, and the cross section area is A. Now what will happen? See, as we have already discussed, the pressure at a particular level, the pressure is same. Now in this side we have only side pressure, and liquid only apply pressure perpendicular to the surface, the surface. So this side pressure, they will be equal, so this side pressure will cancel each other. In the topmost surface, the pressure is only in the downward direction, and what is that pressure? Is nothing but H1 rho L into G. And in this bottommost region, the pressure is in the upward direction, because the other side there is no chance to give the the liquid cannot apply the pressure. This pressure is P2 is H2 rho L into G. So what is the net pressure? The difference in pressure is nothing but P2 minus P1. That is, if you take density common, it will be H2 minus H1 rho L into G. So this net pressure is in which direction? Is in the upward direction. So the force applied will be area A into this net pressure, that is A H2 minus H1 rho L into G. Now see, A into H2 minus H1, H2 minus H1 is the height of the solid, and A is a cross section. It is nothing but the volume of the solid into the density of the liquid into G. So what does this mean? V into rho L is the mass of the liquid that is displaced, and G is, to multiplying by G, what we get? It is the weight of the liquid displaced. So, and this force, as it is being applied in the upward, and the net direction of the force as in the upward direction, the upthrust will be equal to the weight of the liquid displaced. V rho L into G. So we can write up thrust V rho L into G, which is nothing but the weight of the liquid displaced. Now we have we have derived this formula assuming this liquid is stationary. This liquid is not moving. Now suppose this liquid, it is not stationary, but it is accelerating with an acceleration a. Now you know from your previous knowledge, that is, if a body is is in a non-inertial frame, if it is moving with an acceleration, then all the constituents within it gets affected by a pseudo force, which finally will affect the acceleration due to gravity. And we will see that when this whole system is moving up with the acceleration in the upward direction, the upthrust will be V rho L G plus A. And if the liquid is moving downward, acceleration in the downward direction, we will see upthrust is nothing but G minus A. And it is very interesting, if suppose a cylinder filled up with water, if it is falling down freely under gravity, then definitely this acceleration will be G equals to G. So at that time the upthrust will be 0, because G minus G, it is 0. So you will note that in a normal condition, because of this upthrust, as water bubble comes up in the falling cylinder, in a falling water channel, you will see no water bubble is coming up, because upthrust will become 0 when A equals to 0. Okay, now along with this upthrust, we also want to know whether a body will be floating or it will be sinking. Now we have seen that when a body is within the liquid, then what will happen? The upthrust is V into rho L into G, where rho L is the density of the liquid. And what is the weight of the body? Is nothing but V into, if it is totally submerged, V rho S into G. Now definitely the weight is in the downward direction and the upthrust is in the upward direction. So what will happen when the body will sink or float? See, if the weight is greater than the upthrust, that is, this is greater than, that is, V rho S G is greater than V rho L G. If you cancel it, you will find when the density of the solid is greater than density of the liquid, the body will sink. When the weight will be just equal to upthrust, that is, the density of the solid will be equals to the density of the liquid, the body will float just at surface. That is, the body will float just at the surface. And now what will happen? If we say rho S is less than rho L, then what will happen? If it is submerged, this weight will be less than the upthrust, so body will come up. The body will come up, and finally it will be, the upthrust will be balanced by when the body is partially immersed. So you can say, if this part of the liquid, if this part of the solid is immersed within the liquid, say this is VL, we say. So VL is the part which is inside the liquid. So VL into rho L into G will be equal to the total volume into rho S into G. G cancels out. So from this, by taking the part of the liquid, the part of the solid inside the liquid, we can find out what is the density of the solid. Okay, let us do one problem on upthrust. Okay, see, a block of mass 1 kg and density 0.8 gram per cc is held stationary with the help of a string. The tank is accelerating vertically upward with an acceleration of 1 meter per second squared. So this tank is not stationary, but it is moving up with an acceleration of 1 meter per second squared. We have to find out, see, there is a tank, there is a block which is tied with the base of the tank with a string. We have to find, and when the tank is moving up with an acceleration A, we have to find the tension in the string. And also, if the string is cut, then what would be the acceleration of the block? Let us see. Now, first of all, a block of mass 1 kg and density equal to 0.1 gram per cc. So first we have to find out the volume of this mass. So volume you can find out by 0.8 gram per cc. Now see, the tank is accelerating vertically upwards with an acceleration. Now what will be the upthrust? Upthrust, I have told you that it will be the weight of the liquid displaced considered. The G is now modified with the acceleration A. So upthrust will be this volume you have found, the density it is of the water only, so it is rho W into G plus A, as it is moving in the upward direction. So upthrust you have found. Now we have to find out what is the tension in the string. Now try to analyze what are the forces acting on this box. See, this box is having, one is the weight of the box and the tension T. They are pulling it in the downward direction, and the upthrust is in the upward direction, and also the block, the whole system is moving in the upward direction. So we can say the upthrust minus the weight minus the tension, this is the net force acting on the block by which it is moving upward. It will be m into acceleration. Now you have calculated the upthrust. Upthrust will be with using the modified gravity. Weight you know, T is the tension that you have to find out, and mass into acceleration that you know. So from this you can find out the acceleration. Now let us come to the second question. If the string is cut, now whenever you will see a question like this, if a string is cut, it means what? When the string is cut, the tension will vanish, the tension will be 0. This question 1. For question 2, tension equal to 0. Then what is the acceleration of the block? The upthrust will remain the same, weight will remain the same, you can find out. So this will be U minus W will be equal to MA. So from now U and W, you can find out the acceleration of the block. So basic concept of pressure, liquid pressure, upthrust, Pascal's law, Archimedes principle, these are very simple. You have already done in your class, in your previous class 9 and 10. But for 11, 12 and for competitive examination, you have to also apply them with higher concept and solve as much as numerical as possible. I hope you have enjoyed the class. I'll meet you soon in the next topic. Thank you.